Welcome to Zero Knowledge. I'm your host, Anna Rose. In this podcast, we will be exploring the latest in zero-knowledge research and the decentralized web, as well as new paradigms that promise to change the way we interact and transact online. This week, Kobe and I chat with Shumo Chu, the co-founder of Manta Network. We discuss the origin story of the project, how they aim to bring privacy to Web3, the unique accessibility that being a Polkadot parachain enables, the work they do on building ZK tooling and libraries for the general ZK community, their plans for a multi-asset shielded pool, a quick look into the future they have planned for the project, and more. But before we start in, I want to highlight a new video series we have launched this summer called the ZK Whiteboard Sessions. It's produced by ZK Hack as well as the ZK crew from Polygon. In it, hosts Bobbin and Brendan interview top experts in the ZK space and explore the most important concepts and building blocks in ZK. I'll add a link to this in the show notes. It's definitely a great resource to check out. Now, I want to invite Tanya to share a little bit about this week's sponsor.
Today's episode is sponsored by Anoma. Anoma is a set of protocols that enable self-sovereign coordination. Their unique architecture facilitates the simplest forms of economic coordination, such as two parties transferring an asset to each other, as well as more sophisticated ones like an asset-agnostic bartering system, involving multiple parties without direct coincidence of wants, or even more complex ones such as N-party, collective commitments to solve multipolar traps, where an interaction can be performed with an adjustable zero-knowledge privacy. Anoma's first fractal instance, Namada, is planned for later in 2022, and it focuses on enabling shielded transfers for any assets with a few-second transaction latency and near zero fees. Visit anoma.net for more information. So thanks again, Anoma. Now here is Anna and Kobe's interview with Manta Network.
Today we are here with Shumo Chu, co-founder of Manta Network. Welcome to the show, Shumo.
Very happy to be in the show. I'm a big fan of this ZK podcast myself, and happy to be here.
Cool. As my co-host for today, I've brought back Kobe. Welcome to the show again, Kobe.
Hello, glad to be here.
All right. So Shumo, let's jump in. I think it would be great for us to learn a little bit about you. What were you doing before Manta and what led you to this project?
Awesome. Yeah. My name is Shumo Chu. I'm the co-founder of Manta Network. Before Manta, I studied computer science, more specifically distributed systems and formal method at University of Washington, get my PhD degrees. And see a great potential in Web3 space. And then kind of thinking the best way to know space is actually join a company. Then I joined a cryptocurrency company called Algorand, located in Boston, right? And there I met many wonderful colleagues. Some of them already appears in ZK podcasts, like Sergey from XM.
Totally.
Yeah. And I think spent a wonderful 1 year there. My role there is basically developing the Python DSL for the smart contract platforms, right? Basically, I almost singularly done the Python DSL for the smart contract. And then I kind of get back to academia, then doing like a ZK compiler and the ZK plus machine learning research at University of California, Santa Barbara. And then decided to full-time at Manta to building the privacy layer for Web3.
Cool.
That's kind of a brief, yeah.
It's quite a journey. It does sound like Algorand has created a group of really kind of interesting research, cryptography-focused folks who've gone out to do other things. What was it about working there that you think kind of made for these entrepreneurial cryptographers to emerge?
I think in general, Algorand is doing great in terms of curating people in text. I think a lot of times matters a lot, not only the company, also like who you are hanging out with, right? So for example, I know a lot of great cryptographers, and also kind of on my side, I'm learning ZK from my like Algorand days, right? So there are sometimes I kind of just like run into Yorgos, one of the co-founder of Acceler. He just saw me just like reading the papers about pairings, all these kind of things, right? So cool. I think basically at that time, I get a sense of what is the cryptography, like how should we using the cryptographic lens of thinking things, and then kind of realize the power of ZK. That kind of, I have to say, like I would never do this if I'm not joining Algorand and also like kind of hang out and then learn from a group of awesome people there.
Cool.
So,
Were you working on any privacy on Algorand?
I didn't do anything particularly in privacy because I do have a kind of like academic programming language background. It does give me a way kind of like formalizing things and thinking things formally. My day job at Algorand is basically building the smart contract language for them. But my light job is actually study cryptography.
Nice. I actually wanted to ask you, Shumo, because I assumed you're kind of a cryptographer, but actually, how would you define your skill set? Are you cryptography research? Are you applied cryptography? Are you more engineering?
I think there is an analogy like you are like a fox and also a hedgehog, right? I'm kind of like more kind of like fox person. I think I basically get a hand of everything of the technical development of Manta is doing. It's mostly in the intersection of distributed system, cryptography, and also like smart contract platform building, and also a little bit like operations and also setting the strategic goals for the project, basically. Yeah.
Who is the team today who's building Manta? Like, who are your peers? Like, how big is this company? I'm really curious.
So we have a team of awesome people. I think till today we have 24 people. And mostly our engineers, we have about like I maybe get the exact number wrong, like 17 to 18 engineers. Mm-hmm. And basically in different like specialties, there is applied crypto, and there is runtime distributed systems, and there is the full stack / like client software, and then there's DevOps. That's overview. And some of them are in Twitter, like our CTO, Brandon, he's on Twitter. Please follow him. And yeah.
Cool.
Shoma, it would be great if you can describe a bit the origin story of Manta, maybe even around the original paper of the anonymous swaps that you folks released.
Yeah, that's great. So I think when we start Manta, right, then we're thinking, what is a meaningful problem we're going to tackle in the space, right? And privacy is one of the most foundational problem. I think this is actually even like more today. But how can we tackle privacy problems? We have seen there's already some attacks on the privacy problems, for example, like Zcash, like Monero, right? But then basically our view is, yes, Zcash is great. We have a huge respect for Zcash team. The problem here is that this entire Web3 world kind of need more things. People not only need to like transfer their balance privately, people want to do DeFi, and one of the most prominent usage is decentralized exchanges, right? So that's kind of the original vision of the Manta. And then basically, I kind of get back to the drawing board. And of course, the starting point of the study is actually try to really, really understand what the Zcash paper did, right? And then to see, hey, can we actually generalize that to actually adding a decentralized exchange scheme? And we find we could, and also we can do decentralized exchange privately, and also we can making the LP token privately as well. That's kind of the origin of the paper. Yeah.
Shoma, what was the original deployment target for Manta? Like when you were thinking about this decentralized exchanges, were you already thinking about, Polkadot where it is today, or what were you thinking back then?
I think at that time, basically, like our requirement is pretty clear. So we want to have a relatively fast consensus so that the performance is good, basically. And secondly is have a relatively good runtime. And we want to have a high performance virtual machines. And then by then, the choice is really like Cosmos and Polkadot, right? It's basically 2020, like October-ish, we started the project. And we did basically a few evaluations on like the pros and cons and Polkadot and Cosmos. And at the end of the day, like our team is just like full of Rust programmers. We just like to program in Rust and really like the substrate.
That's a good choice.
Substrate blockchain frameworks. It's really like, I think people in Parity did an amazing job to get a blockchain deployment suite as a substrate, right? So that's basically why we choose Polkadot.
Do you want to share a little bit about the landscape, almost like the Manta landscape in Polkadot? I want to sort of set the stage. Right. You have two different networks, and Polkadot always has sort of the canary on Kusama and Polkadot. So maybe we can just sort of like map out a little bit. What does Manta actually look like right now in that Polkadot setup?
Perfect. Yeah, that's a really great question. And maybe I can talk a little bit about where the Manta's vision get a little bit more generalized than just do a private payment and decentralized exchange, right? So the Polkadot has this notion of a canary network. People most know like Kusama as a canary network of Polkadot. So it's a little bit history. Like Kusama used to be actually an incentivized testnet.
Incentivized testnet, kind of. Although I feel like they always pushed back when you tried to call them an incentivized testnet. But yeah.
It's just like the origin when the Kusama just first launched. It's unincentivized. It's not incentivized.
Oh, unincentivized.
So it used to have a token for, it's actually have a faucet. It used to have a faucet. It's very interesting. Like I guess the people get the faucet tokens are very happy right now.
Wow. Really? Wait, when it first launched, there was a faucet? I actually didn't know that.
Yeah.
Wow.
Yeah. So, and then I think basically people think it's a good idea. The thing is, if the token doesn't have any economy values, it just gives a developer different mental model of deploying things. So basically, people think, hey, it's a good idea to have a canary network. It's kind of expected degree of chaos. And then that's Kusama. I think we're following the similar principle as Web3 Foundation and Parity for the Polkadot, right? So basically we have like a Kusama-based network called Kanmari, and we're going to launch a Polkadot-based network called Manta Network.
Yeah.
And these share exactly the same code base and have the exact same set of features, and it actually shares the same binary.
But Calamari is sort of advanced. It's further along somehow, right? Like you've already deployed more things there. I mean, it's live, and Manta isn't.
Yeah. So we're basically the deployment sequence is that we deploy the features first in we call Dolphin testnet. Is actually gone through several iterations of the testnet, and then to Calamari, and then to Manta.
So Dolphin is like a private testnet that only you run on?
Dolphin is a public testnet anyone can try. It's actually working pretty well. The testnet v2, we already have more than 150K transactions, have more than 20K active users in the testnet. I think it's just a very cool experience. You can actually see seamless private payment experience on that. Highly recommend you guys try it. And it's actually just go to Manta Network, then you can just click to try it. Yeah.
I have one more question about the testnet. In a multi-chain, like in the parachain model where you have various parachains that have launched, they have their canary version on Kusama, they will also have testnets. When you're deploying, like, is it the testnet that's actually somehow like playing with XCM to another network's testnet? And if so,
yes.
what are they going through? Is there a testnet relay chain too?
Yes. There's an infrastructure called the Rokuku that's kind of run by Parity.
Yeah. Okay.
I think there are some projects, their testnet don't join Rokuku, but we actually join Rokuku so that we can test XCM messages with other teams. This is actually our kind of daily workflow. We have tested with the Moonbeam team, with Akala team, for example.
Nice. I think later on we're going to go a little deeper into like the status of the project. But before we did that, like I think you had mentioned, doing privacy. What role does a project like Manta have in this ecosystem? What kind of privacy could you bring? Yeah, what would be the use case that you could imagine?
I think there are several questions. Let me try to unpack them. First is that what is Manta's vision, right? I think basically our vision is trying to bring privacy to all the different kind of applications in the Web3 space, right? Not limited to payment, decentralized exchange, and can elaborate a little bit more on like where the Manta project is going, like in the following, right? But this is basically our vision. And what is our current product that is already launched in testnet? It's basically a shielded payment protocol that support multiple assets in Polkadot, and also, I guess, bridged asset to Polkadot ecosystem. So basically, the role of the Manta and Calamari is to be a privacy. You can think of kind of like a privacy as a service for all the like Polkadot ecosystem parachains and also bridged asset on Polkadot. We basically can privatize any kind of asset, and also all these assets are in a single shielded pool. In the sense that one feature we have is that we actually can shield the asset ID as well, which means all this kind of like a long-tail asset will enjoy same level of privacy as a mainstream asset in the shielded pool, right? So that's what we currently are. And in the future, I'm happy to talk about that a little bit. We're actually launching like a native programmable layer for the smart contract. And this programmable layer will be EVM equivalent.
Interesting.
So in a sense that it will be a composable and also EVM equivalent smart contract layer directly on the private asset.
Nice. So this is kind of where your philosophy diverges from the current, let's say, Zcash philosophy or Zcash focus, where their current focus is on a single asset, where you have, transparent and shielded, but it's all like a single asset. I think there's no big effort in bridging anywhere. And you actually chose to focus on that, and also you're kind of touching on composability. So I guess what else would you consider that you diverged from Zcash? What are big differences that you have?
I always tell the team using the analogy, right? I think, again, right, I think Zcash, those guys are doing great. I think Zcash is kind of like a Bitcoin, right?
It blazed the
very
trail.
Intact. Firstly, blaze the trail. And secondly, they have an amazing defensive depth for their protocol designs, right? So a lot of people underappreciate that. Like they have a lot of defensive depth. And we're kind of like we kind of position ourselves more like Ethereum, right? We want to support all the assets people love. We want to support all the activities people love in the Web3 space, like DeFi, NFT, metaverse, gaming, you name it, right? I think there is inherent need for all these spectrums of activities for the privacies, so that we're a little bit more adaptive and try to bring, this is also related to our future vision, that we're going to bring the programmability to the private asset as well. I mean, you can think of analogous to kind of Ethereum brings programmability to the cryptocurrencies, and we are bringing the programmabilities to private assets.
Yeah, that makes sense.
Do you want to talk a little bit about Manta Pay? And what is it? Because I think so far we've been talking primarily about Manta Network or like the company or Calamari. But what is Manta Pay? Right.
So Manta Pay basically is a first project we are launching. It's already live in Testnet, has experienced 2 versions. And the kind of rough estimation is that it's going to be live in Calamari next month. Okay. So we are kind of doing the trusted setup code right now, and we're going to do the trusted setup pretty soon. Cool. So from high level, it's basically a multi-asset shielded pool protocol. And I guess from the feature side, right? So support multi-asset, and you can mint your public asset to the private asset, and you can do a shielded transfer. We do have a kind of like a Zcash style shielded address system. And this shielded address system, first is reusable, right? Like, for example, if you are, for the lack of a better word, hanger artist, you want to post your private shielded address over the internet to receive some donations, you could, right? So it's a reusable public address. And also each shielded address comes with a viewing keys, in the sense that the viewing keys give you the viewing powers of the history, so that you can do selective disclosure and regulation compliance.
For audits and stuff.
And for audits and without giving the spending power. I think that feature is quite useful for even your commercial settings. For example, you're running a DAO or running a company, you have a person in charge of spending, you do want the spending history kind of auditable, right? So I think that's from feature level, what is Manta Pay. And from the implementation level, we do, our amazing crypto team do spend a lot of time optimizing the speed, right? So actually, one of our kind of technical advantage here is that we believe we have a very efficient, probably the most efficient Poseidon implementation in the industry in terms of the constraint. And we have a very streamlined protocol. So it only takes about like 20K, like a RNCS constraint for the ZKP circuit. And this basically translates to a blazingly fast prover time. Our prover time is just like 2 seconds. So it's basically doesn't add any lag for your transaction, people's day-to-day like private transaction experiences.
It's not bad. Wait, before we go into the sort of details of this, is Manta Pay a product? Like I'm trying to figure out, is it an application that lives on top of the Manta network?
Yeah, that's also an excellent question. Thanks for asking this, right? So it can have different forms. So first, the Manta Pay Protocol is running on Manta networks, right? So you have to using Manta network to have the private payment. But thanks to the XCM, right, basically support all the Polkadot ecosystem parachain asset and bridge asset, right? It's the first layer. And second layer, from an end user point of view, like how I'm going to use Manta Pay, right? So you could use our DApp, right? You use the digital asset to our DApp and use that. That's perfect. And actually, we're also developing SDKs and also functionalities to other parachain dApps. Give you an example. Like, so for example, if you are dapping the Moonbeams, you just use our SDKs. You can let your users to one click, like privatize your asset, right? So this is all thanks to the wonderful XCM cross-chain communication mechanism baked in the Polkadot ecosystem.
How does the SDK look like? Like, what is the interface that users are getting? So let's say Moonbeam developers, are they getting something like, I want to make a private transfer and then it automatically uses XCM to go to the Manta network? Like, how does it work?
So SDK in our current environment design, basically, let's say if you are dApp on Moonbeam and you want to privatize your asset, you basically click the privatization. We provide the XCM encodings of what does a privatize mean. You can think of this as basically streamline two things in the same XCM call. The first thing is that to transfer their tokens from Moonbeam to Manta. And second is also feeding the zero-knowledge proof in the XCM call as a message passing. And then on our side, we interpret that as a privatization and generate private tokens for the users.
That's cool.
Going back to Zcash, do you think that another privacy blockchain, maybe like Zcash or, I don't know, like Penumbra or something, could they ever lock into the Polkadot system and do anything like this? Or is it really like by being a parachain that you have that advantage of like actually being able to use XCM and it does something different than what they would be able to do?
I think the question is which kind of advantages XCM brings us. So in principle, right, you can always do things like other, for example, like Zcash, Penumbra you mentioned. If there is a message passing bridge to them, they could do the similar things. But the advantage of the XCM is this cross-chain communication mechanism. First, it's baked in, right? So it's that supported by relay chains, so have much better security guarantees. Basically, you don't have to worry about the bridge security vulnerabilities. And secondly, right, it's very like a programmable, right? I think Rob talked about XCM here, right? It's very programmable in the sense that it's just like much easier for the parachain developers to do that. I think it's always possible to using bridges. Think about XCM is basically a high security message passing and has a certain level of programmability, high performance bridge baked in the Polkadot ecosystem.
Yeah.
It does give a little bit of advantages in this regard. Yeah.
Do you see yourself though also using like other bridges for your privacy, like going outside of Polkadot?
Yes, right. So then we support the tokens outside of the Polkadot ecosystem, right? If we want to support that in our kind of like Polkadot deployment, we want to do that. But I think we are like looking to grow Manta to a multi-chain project in that sense, right? So because I think the inherent reason here is that there are some security concerns over bridges, right? Also, at least the current state of bridges, the things you can do is still quite limited, not as good as native deployment, right? So we actually partnered with Acceler, like on the bridge deployment on Polkadot ecosystem.
Because you guys used to work together, Acceler? Sergey, or what?
Yeah, we used to work together, and also I think it's more about we trust their engineering capabilities. They can making things secure, right? So yeah.
You sort of mentioned this multi-asset shielded pool, and I might be thinking about something that's not related, but it sort of made me think a little about the work that Anoma does. I know that they often will mention this like multi-asset. Is it in any way related?
They even have a project that's called MASP. Like
oh wow, yeah.
It's very similar. So it's kind of interesting. So when we first developed the ideas, I actually didn't know they exist. So the original MASP design is before Manta paper, but I guess I just don't know the paper exists. Kind of reinvented the wheel actually, and then once we actually read the paper, we say, hey, like this like Zcash people actually did this like a multi-asset shielded pool, but the design I wouldn't bore you into the design. The design is a little bit different. Okay. But in general, in the high level, it's very, very similar.
But is it similar to Zcash or Anoma? Was Zcash the first people to do it, or?
So this multi-asset shielded pool is originally designed by Zcash. And then kind of Anoma forks that.
Oh, okay. That's the history.
Yeah. Also, like, I think the Noma guys are amazing. It's actually properly credit that as well, right? So I think in our case, we have no idea. When we first read the paper, we have no idea this thing exists. And after read the paper, hey, we find this. Actually, we add reference of multi-asset shielded pool to the paper, the second version of the paper when we revise the paper. But in general, it's a very, very good design in the sense that I think it's the way to go if you want to have a multi-asset privacy. In the sense that there are going to have some like mainstream asset and long tail asset, right? And then if you put that into a single pool, then this long tail asset will have the same level of privacy as this mainstream asset.
Okay,
that's basically the design benefit you have for the multi-asset shielded pool.
And I guess what you're saying here a little bit is, you know, when you think of a shielded pool, so far we do think of them as all having the same like asset type. And then like say there isn't very much liquidity in it, then you can often sort of spot things coming in and out of it. When you say long tail, you're talking about like things that have low liquidity. There'd only be like once in a while something put in or taken out. But wouldn't you still be able to see either side of that? Like, wouldn't you still be able to track that like, well, they're long tail, there's very little of it. Like, how could you not still reveal?
That's a very, very good observation. So like putting in, getting out, right? This you still see the asset ID. There's no way you can hide that because one end of the pipe is public. But the privacy benefit you get is basically for token transfer. Let's think of a multi-asset design that you actually disclose the asset. Then you actually know like what asset is being transferred if the asset ID is public, right? And let's say, Anna, you're the only one who have this very niche asset, and people can directly spot, hey, your transfer, right? So I think that's concrete benefit for the multi-asset shielded pool have here.
Yeah, I guess like as long as you keep your assets in the shielded pool for a long time, then you will be able to at least wait until other users join and have more of these assets. So don't go out too quick, I guess.
Yeah.
But in this case, is it also that within that shielded pool, there's just like more stuff happening? Like, can you do more with it? Could you use it to do things? So therefore, like, yeah, it's maybe less about like the ownership of the asset, what you could do with it.
That's another excellent question. Basically need to the future direction we're going. We want to basically have a general programmability for the private asset itself as it is without ever converting it back to the public asset. We actually have a very good design here. Actually, try to get the EVM testnet out for the private asset this year. But in general, we think that's could do and should do, and that's where, in our view, the privacy a Web3 project should moving towards, because I think it's really about a user experience problem. Right. So I think it's great we can privatize this asset and transfer to our friend and privatize that to public token and get some utilities. But in general, to be able to actually make privacy more mainstream and to protect more people's privacy, we just need to lower the entry barrier in the sense that people can just use a private asset as they are using normal asset. Mm-hmm. And we think that's perfectly doable. And then basically, the way you do it is that basically you give the private asset same utility as a public asset, where, for example, you can like buy NFTs, you can do DeFi, you can use that in all the metaverse applications, right? So I guess one interesting thing we think here is that let's imagine in the future Web3 world, basically our stance is that we think privacy is not a good to have thing. It's actually a requirement. Mm-hmm. Let me give you several concrete use cases, right? So of course, we want privacy in DeFi because that's your like most important privacy part, the financial privacy. There are many other use cases. I think one use case, for example, is NFT, right? I think the current way the NFTs actually have a biggest privacy leakage in the sense that I have my NFT as my PFP. I submit my address to Twitter to verify my PFP. That's a direct leakage of your personal identity with your on-chain address, right? So this leakage is just so huge, right? So think of you have a ZK-based private NFT. You can still showing off, hey, I have this like wonderful NFTs. Then you just verify that using zero-knowledge proof, right? So you get all the functionalities, but you actually will have privacy.
Yeah, there's actually two places where you could do that even. You could privately prove that you own like an NFT or something in a collection potentially to get access to something. Or I think in your case, you're saying you would not know to which address that NFT actually belongs.
Yeah. So you can still, hey, this is my public profile, right? Then I show that I own this NFT, but it doesn't necessarily have to link to your Ethereum or like a Polkadot addresses, right? And just before we move next, allow me to show you another like applications we have in mind, right? So for example, like in the future of the decentralized organization like DAO, right? Very simple applications like payroll actually requires privacy. Kind of like any organizations. I'm not happy my colleague just earned like $10 more than me in a single month, right? So I think you can see, right? So basically, we're envisioning in the future, like the privacy is actually inherent need. If we are buying the thesis, this Web3 space are going to be more important in people's daily lives, then we think you need privacy from the first principle, right? Basically,
that's where it comes
what we're
from.
looking at. Yeah.
Okay, now I want to spend a bit of time diving a little bit more into the tech stack. And you had sort of mentioned a few things. You'd mentioned the Poseidon implementation that you did. I mean, did you take the work that had already been done and use it? Or did you do something to that? Like there had been sort of these, what was it, like hash competitions a few years ago where they were trying to find these like, do you remember this, Kobe?
The Snark-friendly hash function competition that was organized by the Ethereum Foundation, I think.
Cool. Yeah. Were you taking kind of the outcome of that, Shumo, and then putting it to work, or were you doing something to it?
So we're definitely kind of standing on the shoulder of giants. So there is a hashing competition, and there is a Poseidon paper by like Dimitri and many other great cryptographers. And also, I think in our implementations, we actually look into a Filecoin's Poseidon implementation called Neptune. It has a very, very good specs, right? So basically, we look at all these both papers and implementations, and then our own team make our own implementation using ArcWorks as the backend. I think one thing I want to say a little bit here is that our team actually building our own like a ZK infrastructure called OpenZL. So it's not really anything like super fancy, but it's basically build a like intermediate representation layer, kind of a proof system agnostic. And this has been proven very, very helpful in our internal like R&D. The most reason is that we think the most circular logic are kind of building in this OpenZL, we call Eclair, these like intermediate representations. And then it compiles to both, for example, Arcworks Gross16, it compiled to ZK Garage Planck. In the future, it could compile to Nova, which is a new proof system, right? Because we see kind of this Moore's law, like trajectory of proof system, new and better proof system coming out all the time. And we want to build a IR that can, using this proof system as a compilation target. And partially, get back to the Poseidon implementation, right? Our Poseidon implementation, the high-level logic is actually implemented using our IR. And then we did a compilation to both ZK Garage Planck and also to like Arcworks Gross16 R1CS. I think this Arcworks R1CS version of the Poseidon is super, super efficient.
I feel like I'm hearing more and more projects like this, or like ideas around this, these sort of intermediate compilers, whatever that role is, sort of in between languages to be able to speak to different languages. I mean, I've heard about it within maybe just like regular blockchain in the past, but now I'm hearing about it more and more in the ZK space. Like, would you put something like Circe kind of in that category?
I think Circe is a great example of something similar. Like, they were also thinking about having these different backends, right? And supporting different proving systems and so on. I think it's very interesting that you're working on it, because it's not a small challenge, right? Like, to translate something that is expressible using hashes, let's say, or I don't know, deriving nullifiers or whatever, to both R1CS and Planck in an efficient manner. It's, I think, something that is still like kind of an open problem.
Oh,
right?
aha. I think maybe I can talk a little bit more on that. By the way, this is not done by me. This is done by like our CTO, Brandon. So I think in high level, you could do that. The way you do that is that we get a lot of inspiration from LLVM, right? The thing you want to build is an extensible structure. So basically, our compilation toolchain has two layers. The first layer is the Eclair. It's a proof system agnostic IR that describes the high-level logic.
How does it look like? What would be the opcode?
It's just a Rust. It's just a Rust. There's no opcode. Yeah.
What I mean, like in the Rust, do I write like this is A times B equals 0? Or do I write like I'm hashing using SHA-256? Like, what do I write?
So I think it's closer to letter, but we have a kind of a try to maximizing the usage of a Rust generic. We have a notion of the compiler. So in the sense that all this backend, whatever they support, expressing the Rust the trade interface, and then plug in as a like generic argument as a compiler. That's why I mentioned LLVM, right? It's really extensible in the sense that we can be using this to staging different like expressions of the computation logic at different layer. Right. So it's, I think to the first approximation, you can think of something like a Rust DSL. We don't have a front end yet, right? So I think it's just like currently just like internal purpose, but we do want to make it open source. And we actually applied for like a Polkadot ecosystem fundings to make it public good. But get back to the technical design, right? Basically, there are two layers. The first layer is expressing the computation logic. The second layer is where the optimization comes through, right? The thing is, you do want to express proof system specific optimizations, right? This kind of, in our notion, we call it a compiler. Basically, you plug in this compiler and you express the proof system specific optimizations in the second stage, in the sense that it's not completely agnostic, right? So basically, we write adapters for R1CS, for basically Gross16 based in R1CS, and write adapters for Planck, right? So this adapter are actually not in generic level and can be application level adapters as well. Basically, that's the thing, right? So you could express Poseidon specific optimizations in these adapters. That's why I kind of bring the extensive design of LLVM here. If you're familiar with the LLVM, right, it's kind of like a building some like extensions and backend of the LLVM. So it actually helps the team a lot. The developer effort already pays off in the sense that we're kind of evaluating whether we're using Planck or using Gross16, right? And after we benchmark, it showed like overwhelmingly advantages to actually using Gross16 as a proof backend. And our team being able to basically switch the backend in like 1.5 hours from Planck to Core 16, for example. That's actually give us a lot of confidence to keep building this infrastructure. Yeah.
Nice. So like this kind of app-specific optimization that you mentioned, I guess they could use things like custom gates or lookups and things of that sort.
Yeah, exactly. For example, in the application-specific adapters for Planck, we actually leverages like higher than standard weights, customized gates in Planck to have a more optimized Planck implementation as well, for example.
You just mentioned, actually, you used the term ZK Garage Planck, which I don't know if our listeners are that familiar with ZK Garage, but I know you've been very, very involved in that effort. Do you want to just explain a little bit what that is? And actually, I want to know, is that a new name for Planck, for a type of Planck, ZK Garage Planck? Because I hadn't heard it. Anyway, first explain ZK Garage, though.
ZK Garage is a community-driven effort to build a public good Planck. There are several people involved. I wish I can take all the credit, but the truth is, I'm just one of the contributors. The effort majorly led by Luke Pearson, one of the Polychain partners. And also there are a lot of amazing people all over the places, from project like Ethereum Foundation, like Anoma you just mentioned. I think Kobe is kind of active in at least in the discussion.
Guilty, yeah.
I think it's a really nice common good Planck implementations. I think two of our team members, Todd, our cryptographic engineers, and also our CTO, Brandon, they all contribute to ZK Garage Planck. And I think also they did at least quite a few educational tutorials for Planck. Like, for example, one of our cryptographic engineer, Todd, he actually gave a general ZK tutorial based on that.
Cool.
On the line hack organized by Columbia students. Yeah.
Nice.
I think it was another ZK podcast perhaps, but
I think you might be right.
I just briefly introduced the community effort here. Yeah.
Cool. And actually, I think I call it like ZK Garage because of my North American accent, but given that Luke is British, I believe, that it would be ZK Garage, I think is more how he pronounces it. Am I right? Something like that. Anyway, maybe I'm doing it totally not justice, and we should probably have him on the show to talk more about this at some point. Okay. But so is that now a type of Planck? You know, people have used the word Planck in various ways, but would that be almost like a standalone, distinct Planck if it's a ZK Garage Planck?
Yeah, I guess in some sense we have like a few Planck implementations going around, right? So you could have chosen any of those, like the Halo 2 one or now the Espresso one, let's say. Why ZK Garage?
From our view, right? So we want to having optimize Planck implementation first, right? So I think basically instead of using all these Plancks, we do have some of our own ideas of actually how to do the Planck implementations. I think Planck is very kind of like you said, it's an umbrella of many different things. Basically, there is a Planck original paper, and there are a few other papers adding things, for example, like a turbo Planck, and then there is a paper called lookup, right? Basically, kind of doing the lookup in the Planck side. The ultimate reason we're using ZK Garage Planck is that we see pure community-driven, independent projects that have a long-term maintainabilities for going forward. That was at a stage we are kind of leaning towards using Planck, and we also want basically our team to be part of the design and also the implementation of the Planck. I think our team still are very happy to contribute to the ZK Garage Planck today, even if our production moved from Planck to Core 16.
I sort of want to go back one step back to that compiler role, because I did wonder, since I am hearing about more and more projects trying to do this, like, would it not make sense for there to be a standardized version of that? Like, why is it good that everybody's kind of developing their own glue between these different pieces?
Yeah, this is the place where you put the XKCD comic where, You have 14 standards, so it's time to make a new standard.
Yeah.
Now you have 15. Well,
I think there definitely is. It's just like I'm more like a practical person, right? So from the practical point of view, if you have a product shipment deadline, right, you do want to say, hey, like your team have a clear understanding of how things are going. In some sense, it's not that bad, right? So basically, like we have good communication with the Noma team about their VMPAM IR. We basically learn from them. And the reason that we decided not using VMPAM IR is that we have very, very different design goal. For example, the IR we're using is not VMPAM IR. It has dramatically different design goals. We also talked to Filecon team. So they have a new language called Lark, right? So you can think of that as a different language. Let me just briefly compare VMPAM IR and the Eclair we're doing and the Lark, right? Lark is a very high-level language. It's basically Lisp, right? It's great for like people who actually doesn't understand anything about ZKP, right? But it actually misses, at least in my view, some of low-level optimization opportunities, right? So that's Lark. And VMPAM IR is on the opposite, right? I think VMPAM IR is great like intermediate representations, right? So, and we're actually thinking in the long term, we potentially can compile our Eclair into VMPIR. The Eclair we're design, we just like vaguely named it IR. It's more like a library and an extensive framework that I just talked about several minutes ago, basically to allow you to freely express both high-level like semantics and low-level optimizations. For lack of a better word, it's more like a LLVM framework rather than a dedicated IR, right? So you can see we are aware of the different development in the space. It's just like currently we don't have anything that we just can use fulfill our need seamlessly. That's why we're building this like Eclair and OpenZL as a library in general, basically.
That's interesting. I mean, I'd sort of already mentioned Circe from Alex Ozdemir, which I guess falls in a similar category. I don't know if you are aware of it or if you've like talked to him about that.
Yeah, of course.
But is that at a different place as well? Like where on that spectrum would you put it actually?
Circe is kind of in the similar to VMPIR to some extent. But I wouldn't say the Circe is the same as VMPIR as well, right? Because Circe, they have, there is a thing called a SMT solver, right? Basically, you can think of it as like above the set solver, right? They have this kind of like a fancy solver-based optimization design baked in Circe as well, right? So it's a little bit more research-oriented for Circe. I'm not saying that it cannot be getting production. It's more a little bit like research-oriented because they have potential to having like a SMT solver-based optimization baked in Circe, right? So, but in terms of the spectrum, the closest thing to Circe is actually the VMPAM IR that Anoma is building right now, basically.
Got it. I know of at least one more project, but I think they might still be in stealth. But I do wonder, like, just general ZK DSLs, this map of how things are working together, do you also have to include the kind of individual project DSLs into that? Or is this kind of compiling, living in a different part? Like, it's almost the question here is like, would other languages also be interacting potentially with your IR, you're calling it, I guess, intermediate representation? Is that what that stands for?
Yeah, exactly. That's a very, very good question. I can like elaborate a little bit more here. Basically, we definitely could have a higher level like front end, right? So it's basically because like our team of cryptographers, they are like a ZK expert, right? They are able to write these low-level primitives and also to do dramatic optimizations so that our ZK circuit is fast, right? I think we can definitely build in a higher level abstractions on top of that. And also, for example, there are some front-end languages we can plug in, things like Circum and Cairo, for example, right? So this is definitely doable. And in terms of the language design point of view, I can only speak for myself. I kind of like Cairo a little bit better because it actually exposes the like a fat and field as a raw element, the primitive data type, at least allow you to having some expressivity of the optimizations in the higher level language. For example, compared with Circum. But in principle, right, all these things can be compiled, right? And I see if there is not enough interest, and also again, like our like IR stack will be Apache licensed as a public good project. We'll definitely welcome people to help us to actually build a higher level stack. But currently, our team will be focused on the infrastructure, the library, the backend to make it rock solid, right? So I think I definitely see the possibilities, and we're also open to collaborations, basically. Yeah.
Got it. You just sort of mentioned Cairo, but everything we've been talking about is Snarks. So do you have any like Stark or Fry, anything in your stack that sort of touches that?
So currently we don't, mostly for efficiency reasons and also the proof size reasons, right? So I talk about Cairo because Cairo is a high-level language, right? That's the beauty of abstractions. So you can compile Cairo to Snark. There's nothing kind of like 100 inherent, like Cairo, or some fragment of the Cairo, like a high-level language design like Cairo, you can compile that to Snark. There's no inherent reason you cannot do so, right? So that's what I'm talking about. Yeah.
Yeah, I even heard about some projects that are trying to do that. So it is definitely doable and interesting.
Yeah.
You sort of mentioned that you're doing a trusted setup, but I'm curious, like, you already have Calamari live. Have you already done a trusted setup for that, and you're making a new trusted setup for Manta Network deployed on Polkadot? Or what is the trusted setup for that you just described?
So Manta and Calamari were using exactly the same ZK circuit.
Okay.
And the Calamari were doing the trusted setup either later this month or beginning next month for Calamari, basically.
But how does it run already? Like, what are you running then? Because it's live, but there's no trusted setup underneath the hood. You haven't done one yet, basically.
So this is basically the modular and also the runtime upgrade. The current Calamari run as a kind of like a generic, like a parachain. It's joined the Kusama networks, but the Mari Pay hasn't been deployed to Calamari yet.
So is it not private right now?
So so the current kind of Manta Pay version of the Mari Pay is going to be deployed on the Calamari sometime next month, right? So, but that's after the trusted setup, basically.
Okay, so like the Snark portion of Calamari is not deployed currently. It will come soon.
Yeah. So,
okay.
So the current Calamari, it has its native tokens. It has a governance. We already removed the sudos. Basically, all the kind of like a shenanigans that getting a parachain up and running, all the DevOps, all the decentralized validators there.
Okay,
right?
I see.
So in order to introduce let's say the Snark portion after the setup, you will have to do this kind of governance proposal to get that to happen.
Right. So this is a runtime upgrade, goes through the governance proposals. So I guess this is another thing that kind of advantage in using a Polkadot substrate, right? So basically the runtime upgrade is part of the infrastructure. So for many other chains, I know it's just a little bit headache to do the runtime upgrade, adding features. But here, it's just like a daily standard practice.
Can we touch on the general purpose privacy that you're planning for the future? This kind of composable thing?
Yeah, perfect. So like I said, right? So we have a bulletproof private payment protocols already working. And the next step is getting programmability to this private asset. Instead of talking that from tech point of view, maybe I should talk from what does this brings to developers and users, right? I guess the first is that to the developers, you can deploy your favorite Solidity-based smart contract into the platform, and this can directly manipulate the private asset in the sense that the private asset will be providing as the same interface as ERC20, which for fungible tokens, and ERC721 and ERC1155 as for NFTs, and potentially many more as a composable interface. So the app developers, they don't have to learn ZK. They can just write a Solidity dApp, and this dApp can seamlessly working on the private asset. That's to the developers. And to the users, and you don't have to worry about that. As long as you are using the dApps are adopting this private asset, we actually spent quite some effort developing the wallet infrastructure to putting things, for example, putting the ZKP generator into a wallet like a Talisman, like a MetaMask, Snap, right? So you don't have to worry about that. You just use the private asset as if you are using public asset, right? So that's the end goal. And we are actually pretty close to that to get these private we're still coining the term right now because it's a little bit confusing. It's not ZK EVM because ZK EVM actually doesn't have privacy. And also we're not privatized the entire part of the EVM. If you guys having some ideas of what is the term here, we're happy to listen. For lack of a better word, let's call it this new EVM design that support composable privacy. It's quite a known word, but that's basically the high level goals we want to achieve here. And I think nowadays it's popular to say things like alpha leak. I think we're definitely trying to disclose more information, including the design and how does things work, and also how when people can play with the testnet in the following months. And I guess keep an eye on us. Yeah, pretty excited.
It's funny because I think a naming standard you could employ if you wanted to. Like it used to be ZK rollup, and then there was ZK rollup, which was like the private ZK rollup. But I know you said it's not exactly EVM, but like ZK EVM, maybe? I don't know. I've even heard that.
Thanks, Anna. This is one of the candidates we're going to consider. Maybe we'll send you an NFT if that's
a private NFT though.
Private, yeah. Only if it's private.
NFT.
Okay.
Yeah, exactly. Yeah.
Cool. All right. Shumo,
Great.
I want to say a big thank you to coming on the show, sharing with us Manta and its kind of journey to now and what you have planned.
That was great talking to you.
Thank you for doing so much work for the entire space. Yeah.
Cheers. I want to say thanks again, Kobe, for co-hosting with me.
Happy to be here.
Thank you, Kobe. Yeah.
And I want to say a big thank you to the ZK podcast team, Tanya, Chris, Rachel, and our kind of guest editor for this particular episode, David. So thank you, David, for taking over from Henrik. And to our listeners, thanks for listening.